Judson and Giles Corran are about to see some plants and animals that are truly beyond belief. Are these modern-day Frankenstein's monsters? Or could they transform our lives and the world for the better? For them and us, it's time to decide. Giles's tour around our farm begins in the cowsheds. He's going to meet some extraordinary creatures, the Schwarzeneggers of the cow world. In the cowshed, the man in charge of the beef herd is Patrice Lobe.
He's a big fellow. Am I all right?
He's quite big, huh? He's 160 meter tall, yeah.
If I saw a man like that,
Yeah.
but I wouldn't get this close to him, I don't think. I would think he was on steroids or something. I think he
No.
was a bodybuilder.
It is 100% natural, whereby, let's say, within so many generations, all breeders have taken the best of the best, or the more muscle of the more muscle. We moved from a normal classical type of animal, and then we select that sort of animal based on the double muscle.
And when you say double muscled,
Yeah.
do you mean it has two of every muscle?
No.
Because it looks like it does in
Absolutely.
almost,
It has
doesn't it?
exactly the same type of muscle than any other breed, except that in terms of quantity, each of these muscles is by far more developed.
Right. This cow is technically known as a Belgian Blue, and it's the product of selective breeding.
Selective breeding is the first stop on our tour of how man is using science to control nature. It's used by farmers to enhance desirable characteristics in their animals. In fact, selective breeding is all about managing sex. To create these Belgian Blues, over 100 years, farmers have only allowed the cows and bulls with the greatest muscle mass to mate. And the result is a bull that weighs over a ton. The animal's breeders are keen to show off the results of their hard work. The bulls are shaved to best display their muscles.
What they try to do is to clip the animals in order to highlight all the muscle. You see?
Well, so you can see where all the meat is. That's going to be.
Exactly.
But even here, where they've sort of trimmed in there.
Yeah, to highlight that muscle, which has got a high value. You see?
And these are all going to be lean cuts, and they're all for quick cooking, are they?
That's right.
Because when you look at this, you can't help thinking of lunch, you know? Is it healthy?
The animal, you mean?
Yeah.
Well, the animal is as healthy as another intensive producing animal.
So this is about the most technological that meat can get.
Not the most technological. In terms of technology, we talk about selection, natural selection, having achieved that.
So what is the science behind the Belgian Blues? There is a gene that regulates the growth of muscles in cattle. These cows have been selectively bred from animals that contain a copy of this gene which doesn't work. As a result, their muscles grow far larger than normal. To ensure the defective gene is passed on, sex for the Belgian Blues has been replaced by technology in the form of artificial insemination.
He is basically a sperm machine.
He is a sperm machine, absolutely.
It's very early in the morning for...
I understand.
The semen is now collected, it's in the artificial vagina, and from there we will process the semen in order to be able to process artificial insemination on the cow.
So precise is the technology involved, they can analyze the semen sperm by sperm to choose the ones they want. So this is this is testing the sperm count.
That's a sperm analyzer. It's now checking, let's say, the quality of the sperm we have been collecting this morning. Green is good because you see that they are very, very mobile and they are looking forward to move towards the eggs.
And these are not especially muscly sperm.
Don't you find that they are very muscled?
Well, they look impressive to me, but I've never seen any other bull sperm. They're not.
Visually, you won't see any difference. There is no way to find any difference between the bovine, the equine, and the other species. No.
Right. Well, I found the whole experience deeply disturbing. They call it natural selection, but it's been designed by men to exploit animals for their own ends.
These chickens may look normal, but they've been bred to grow as fat and as fast as possible. Greedy chickens have heart rates as high as 300 beats a minute. They have a high metabolism and find it difficult to cool down.
In charge of solving the problem of overheated chickens is geneticist Dr. Avigdor Kahana.
As long as they are kept in cool environment, this is not a problem at all because this heat is dissipated through the legs, through the face, and that's sufficient. However, once the progeny of these birds are reared in the tropics in hot conditions, because the gradient in temperature between the body temperature and the ambience is so small, they can hardly dissipate the heat.
So it's as if I go to the tropics wearing a fur coat,
That's right.
and I just can't get cool enough.
That's right. Since I'm a geneticist, I was looking for a genetic solution. That means instead of cooling the environment of chickens with feathers, is helping them feel cool by just removing the feathers. So I decided to go to the extreme situation of developing broilers without feathers at all.
Can we have a look?
Sure, let's go.
All right. Chickens without the gene to make feathers. I'm fascinated to see what they look like. God, it's hot in here.
Yeah, it is hot.
And here they are, the featherless chickens. They look like miniature dinosaurs.
What we have here is that's the original mutant. This is a female.
She's amazingly smooth.
Yeah.
It's quite extraordinary.
This is the male.
So
And as you can see, no scales on the feet.
Right.
That's why the mutation is called scaleless.
They've got little claws on the ends of their wings. You can certainly imagine them as little miniature dinosaurs.
Yeah. The sexually mature males
They're bright red.
become red. It's an interaction between the sex hormone and the light,
I see.
which create this red
So it's
pigment.
testosterone plus light makes
Yeah,
turns you red.
That's right. These are adult birds. This is mature body size. They will never be bigger than this. When I started to cross birds like these ones
With the ones
with the ones that we saw. Well, they try to flap. They still know how to flap.
they're rather sweet. Having successfully bred small featherless chickens, Dr. Kahana wanted to see if he could create a big commercial-sized bird.
That was the challenge, and indeed we managed to do it, as you can see here.
He's huge.
This is an
He's
adult
absolutely
male.
huge.
This male is identical in body size to the males that we saw over there in the other house, which have full feathers. The only thing that we changed is that we took advantage of this gene, the scaleless gene, that eliminates or avoids the development of the feathers. And by doing this, we allowed these birds to grow nicely and comfortably in hot conditions.
These chickens are the result of Dr. Kahana's selective breeding program. And after 6 generations of mating the chickens with the featherless genes, this is what we've ended up with. I can imagine most people's reactions at seeing these chickens is one of revulsion. But if you were a chicken in 100-degree heat, you wouldn't want feathers, believe me. And anyway, they're not the first animal bred to have their natural covering removed. Look at pigs. Wild boar are furry. And even we humans were once apes, entirely covered in hair. So perhaps they're not as weird as they first seem. What is the future of these chickens? Are we going to see them in our supermarkets soon?
Hopefully in the supermarkets in the tropical countries, in Nigeria, in Indonesia, where it's very hot. For these farmers, it's easier and more efficient because there's no need.
You don't have to pluck them.
That's right. There's no need to pluck them. The proportion of meat on these birds is higher.
So featherless chickens in the tropics, they grow faster than a bird with feathers because they don't get held up by the fact they're getting too hot. They're healthier, they cost less because you don't have expensive housing. It sounds fantastic.
That's right.
Good for the person, good for the bird.
In case you missed that, Dr. Houdeveen has successfully used transgenics to insert a jellyfish gene into a rabbit.
And what does the gene do?
The gene gives green color to the jellyfish and then green color to the rabbits.
So the rabbits glow green in the dark.
Yes, absolutely.
Can I see?
Oh, sure.
Charged up with blue ultraviolet light and viewed through special glasses, the skin and the eyes of these rabbits glow green, just like a jellyfish.
Look.
Oh yes,
Yeah.
extremely green.
So the
That's
difference
amazing.
is great because they have red eyes
Yes.
in normal light and green with this light.
It looks quite peculiar, I must say.
Yeah.
This is no trick of the light. These rabbits' eyes and skin really do glow green. It's amazing what he's done.
This is transgenics in action. Scientists have managed to isolate a tiny bit of jellyfish DNA that makes them fluoresce, known as the GFP gene. Dr. Houdeveen has simply taken that gene and inserted it into bacteria. As the bacteria reproduce, the gene is multiplied. And then these genes are injected into the fertilized egg of a rabbit. Dr. Houdeveen then places the egg into the mother. As the egg grows to form the rabbit embryo, it copies the fluorescing gene into every cell. 31 days later, you've got fluorescent bunnies. In the fish tanks on our farm, Joe McGonigal is using transgenics to create a salmon that grows extra fast for your dining pleasure.
So down here in this tank, we have transgenic fish that are a year old. During this period of their lives, they're growing about 4 to 6 times faster than standard salmon grow. We can take this out and we can compare it with a standard non-transgenic salmon, and you can take a look and see how they compare, both for size and for condition.
After just 1 year's growth, Joe's salmon are 4 times larger than non-GM salmon of the same age.
Well, what we have are 2 same-age fish. The larger one, as you can see, is the transgenic that we've just taken out of the tank. These fish are virtually identical, except for one has a transgene. It grows faster during this first year of life.
Traditionally, a salmon only grows in warm water. But as soon as the water gets cold in winter, the gene controlling the salmon's growth switches off, and the fish stops growing. Not anymore. Joe takes the genetic switch which controls growth from another species of fish that grows in cold water. He inserts that into the salmon egg. The presence of this genetic switch means the new salmon now grows all year round, whatever the water temperature.
I like bacon as much as the next person. But the amount of pork we eat is causing serious problems. Last year, we killed more than 2 billion pigs. And these creatures provide more dietary protein, more cheaply, to more people than any other animal. But all this consumption comes at a cost. Manure. It's a natural product, but on an industrial scale, it's a serious environmental pollutant. And poo from pigs is particularly toxic. Pig manure is packed with phosphorus because pigs simply can't digest it. And this excess is causing some serious damage. It runs off into the water supply, causing the overgrowth of algae and killing fish. It seems an impossible problem of biology, but John Phillips has found a way to fix it.
A very simple and effective solution to the environmental problems caused by high phosphorus pig manure found right behind these doors.
tackle the problem, John has created something he calls the EnviroPig. This animal looks normal, but it's anything but.
These pigs are unlike any other pigs in the world. They're different because they carry a very special gene that allows them to digest all of the phosphorus in their diet. The gene is constructed in the laboratory that we use.
The remarkable thing about the EnviroPigs is that they carry a man-made gene, which John has created from scratch.
One part comes from E. coli bacteria, which produces an enzyme that can break down phosphorus. And the other comes from a mouse, which produces a genetic switch that allows this special enzyme to be made in saliva. These two bits of DNA were combined to form a new compound gene, which was then inserted into a fertilized pig egg. Now every time John's pigs eat and produce saliva, they also make the phosphorus-busting enzyme, helping to make their poo more environmentally friendly.
The aim ultimately, we think, is that the global environment would be best served if every pig could digest all of its organic phosphorus in its diet the way these pigs do.
So John wants every pig in the world to be an EnviroPig. I think it's an idea with merit, but he's encountered a lot of obstacles.
There are many people out in the community that do have concerns about transgenic changes in animals, and some of these people have gone about intentionally frightening the public about this technology. So we have an uphill battle in terms of people's perceptions. This is an effective way of dealing with a serious environmental problem. It's simple, it can be propagated very rapidly. Any other technology cannot touch this in terms of the rapidity of its application on the farm or the extent of the change that can occur as a result of the technology. Nothing comes close to this.
I personally would much rather eat an organism that has been genetically modified to grow fast than one that has been injected with a lot of hormones to grow fast. I certainly would have no objection to eating an animal that has been genetically modified. I mean, what is a gene? It's an instruction to make a protein. It's not anything mystical.
I think to a lot of people it probably is something mystical.
But it's not. I mean, there's nothing mystical about a gene. We know what it is, we can describe it, we can build them. There is nothing mysterious, and all it does is contain the instruction for making a protein. You know, you add one, you take one away, so what?
But having understood how it works, to then start changing it and meddling with it, is another step, isn't it?
Well, we already have. I mean, nothing in this countryside, in this landscape, is natural. It's been modified by us. We haven't done it precisely, but we certainly have altered which sheep are growing, which grass is growing. We just don't have such a thing as a natural landscape in most of the world. I mean, it's just complete, you know, it's a fantasy. We've created it.
Once scientists have gone to the trouble of improving on evolution, either through GM or traditional breeding, the next question is how to preserve their success. And now we get to the most extraordinary technique scientists are using on our farm. Cloning. You've probably heard of Dolly the sheep, but what you may not know is that since then, scientists have created whole herds of cloned cows, pigs, and flocks of sheep. For our next stop, we're going to meet the prize-winning herd of longhorn cattle, an entire paddock of clones.
The adult cows are surrogate mothers, and all of their calves are clones. In this pen, I have clones of 5 different animals.
When you say surrogate mothers, did they carry the eggs?
They carried the embryos, the complete gestation, and gave birth to these calves. Everything is as it would be
if they were normal.
Weren't, right. Well, if they weren't clones, so.
You don't like to use the word.
Well, you know, looking there, you can't say that they're abnormal.
No, they look very healthy,
know.
and
yes.
Although they're beautiful and lovely, and I always love seeing cows, and particularly small ones, I'm slightly disappointed that they're not all identical.
You know, cloning, you can't guarantee that they're going to look identical. You're just guaranteeing that the genetics are identical. That's the purpose of cloning, is to provide the exact genetic.
I kind of expected them all to be running along together in rows, you know, like finishing at the same time in a race.
Yes,
like a mirror image of the same cow over and over. So it's not quite like that.
No, it's not. You know, like I said, they'll act similar, but they don't know they're a clone, and each calf has its own personality.
Today we're working with bovine.
So it's a cow egg.
Yes. These eggs come from a slaughterhouse, and what I'm basically doing is taking out all the DNA and creating a blank for the actual cloning process to begin.
So in order to clone, you need an empty egg.
Exactly.
And so you're plunging this glass pipette into the egg and just suctioning out the DNA.
Yes.
It's an extremely delicate operation.
It is. You have to have good hand-eye coordination and have to be gentle with the eggs. You don't want to kill them.
And that's what's amazing about cloning. It doesn't require particularly complicated chemistry, just a microscope, a very sharp glass needle, and incredibly steady hands.
And I'll go in with the pipette.
And draw it up like juices from a turkey. I have to say, it's fascinating to see it.
Next, Earl has to hoover up the cells containing the DNA of the animal he wants to clone.
These are cells grown from the skin of the animal that we want to clone.
Exactly.
It amazes me that you can put a cell from a grown-up animal into an empty egg and something happens.
Well, the cell basically contains the whole genetic makeup of that animal.
You now insert the DNA of the animal you want to clone into the empty egg. One cell into each
You
egg.
can see there's a little pocket of space.
What I'll do is puncture the egg and just carefully deposit the cell in there.
Last of all, you need to wake up the egg containing the new DNA. All it takes is a spark of electricity.
Olivia has one last surprise up her sleeve. And it's one of the most revolutionary concepts we've encountered. You will never have seen this before.
One possible use of genetic technology is to just get rid of the animal altogether and just grow steaks in vats. I know this looks a bit unappetizing.
Oh, no.
It's
Depends what it is.
well, it's a prototype steak in a vat.
This is meat grown in a Petri dish. A burger from mince that has never been part of a cow or bull. It opens up a world where no animals need live or die to feed you.
It's grown from stem cells.
It's grown from stem cells?
Not human stem cells. Cow stem cells.
Right.
This prototype non-animal burger may look slightly odd, but you could just be looking at the future of food.
You could just grow a hamburger in a vat, or grow a large piece of breast meat in a vat, and get rid of the animal altogether. And so if you're worried about the ethical treatment of animals, you might then want to start eating meat again.
Surely you couldn't make one of these tasty. Part of the life of the animal is what makes the thing tasty, isn't it? I mean...
I'll have to do the experiment.
We have gone to all this trouble to prepare this food, so might as well eat it. Do you want to start with the... do you want to carve the super salmon?
Well, cheers. To genetic modification.
To Mother Nature.